And we are live. Happy St. Patrick's Day, smAsho viewers. Welcome to another Space Weather live stream. KP index at 4. Geomagnetic Unrest. A property more common during equinoxes. We'll get into it. Let's look at a 48-hour video of the sun on 193 angstroms. We do see a coronal hole rotating out of the Earth-facing region. The North Pole coronal hole has kind of reopened there. Still not as large as it was a month ago. All right, let's look at some other views here. Here's the magnetic lines. I would note that I don't have my Epic pen. I would note that you've got some magnetic complexity associated with this active region over here. And we have 0 sunspots, by the way. And let's take a look at 304 angstroms. See if there are any filaments or anything going on. And here's a 304 angstroms view. While that loads, let me see if I can find the chat. And let me take the opportunity to thank our viewers. And let me just get the chat out here. Thank you, Harry Wire. You dropped by. Oh, you dropped the DAP 2030. All right, well, you can go back. It'll never be now again, right? Anyway, there's the view at 304 angstroms, looking at the last 48 hours. Not a whole lot going on, although we are in geomagnetic unrest with a KP4. Don't absorb my window. All right, let's look at the real-time solar wind. Slightly elevated numbers here. Now, keep in mind, this is more potent at the equinoxes. We see a very high BT here, the black line. The BT is all the way up at 7.8 or so. And the BZ is very negative, around negative 3.5. So not super low there on the BZ. And we don't see any kind of coronal hole magnetic connections currently going on. A couple sputters in this area, and in this area, and back here. But pretty smooth sailing as far as coronal hole magnetic connections. We see a 6.56 proton per cubic centimeter density there. And solar wind at 411 kilometers per second. Here's the gong 2. And we are expecting to see some spikes in the magnetometer here, and I'll show you why. So, we are now in the part of the current sheet that is charged by the North Pole. Actually, let me advance that to the final frame. So there's the last frame. Keep in mind that's about 2 hours old. When you see these bulges like this, that indicates a very direct magnetic field force lines right to the corona. So in the next 24 hours, we do expect to see some big magnetic spikes due to this region, and it will be evidenced by the GOES magnetometer. Let me just talk about the equinoxes here for a second. There is an article on Space Weather about this. Let me see here. There you go. There's a graph for you. Geomagnetic disturbances are almost twice as likely in spring and fall versus winter and summer. So this is the kind of thing you typically see around the equinoxes, where a solar wind speed that isn't that high is hitting the magnetosphere at more of a significant angle of attack, making it a little bit easier to spike the high KP indexes. And to quote spaceweather.com, opening cracks in the Earth's magnetic field. We were at storm level there. We were at KP5 for a little while, but that's come back down. And 10.7 centimeter radial flux still at 70, so no change from yesterday. Let's look at spaceweathernews.com for a little added data. No real X-ray flares there. There you can see the KP was 5. We got a very low reading on the magnetometer. And this is going to spike back up in the next 24 hours, so look for that to happen. Although we're not expecting to see any of these weird perturbations like this. The crossing of the current sheet was this area right here, by the way. And there we see a dip in the electron flux, which we typically do. Think proton to electron ratio. A little bit of charging hazards there. And the F2 layer is looking pretty normal again. A little bit of charge out front there that might be a little bit out of the ordinary, but looking fairly normal. This got very charged up yesterday, by the way. It was all the way up to 14 megahertz. And why'd you refresh me? All right, there we go. And there's your aurora forecast. We have big auroras. It looks like even Minnesota and South Dakota might be getting some auroras there. If you're in like East Central Canada, very likely to see some. And there's the aurora australis, also huge. So let's move on to the Space Weather Enthusiast dashboard so we can run the Enlil forecast here, as we typically do. Just to give you a little better idea of what the predictions are. And while we're here, I would note stereo A and stereo B. And why isn't it playing? Okay. Well, that was different. Let's try again. There we go. All right. So we see the forecast is actually calling for a slight increase in the plasma density throughout the day. And an increase is expected to begin tomorrow in the velocity. So I'll let that play through one more time before moving on to the total electron content. Now we did see a big dip in the electron flux. We like when data corroborates, so here is some. You notice it gets very dark over North America. That's electrons, a low electron density. Right there, very dark over North America. So the electron flux dipped, then it came right back up, an indication that the current storm conditions aren't super strong. Let's look at the magnetosphere as it's quite charged up. Just start playing all of these so that we spend the least amount of time waiting for things to buffer and keep the content as dense as possible. I am a bit of a blonde and been known to be quite dense myself from time to time. Here's your geospace magnetosphere movie for the velocity. We see some quite high velocity zones and some big perturbations in this. That's what you call geomagnetic unrest. Here's the density. These movies give you a good idea of the different factors involved with the solar wind and how they affect the magnetosphere. Keep in mind, they're just models, but they are based on lots of measurements. Thanks to the University of Michigan Geospace Department, I guess. Do they have a Department of Geospace? We'll just say University of Michigan. There's your pressure. And we see quite high pressure. We're expecting the ionosphere to charge up again today, pretty high. Let's move on to the ground perturbations. As we saw big ones last night, let's see if they continued. We did see a bit of a change in the perturbations, which we will go over momentarily, especially if they're still there. All right, so on the North Pole side, we see the main changes in the field are more up toward Iceland as opposed to more toward central Canada, and less perturbations around Siberia. Actually, it kind of switched. All right, so that's interesting. And on the south side, the South Pole actually looks like it's closer to Antarctica now than it was, say, yesterday. Anyway, here's the globe view. We'll let that play all the way through. So some big perturbations there around Iceland. And some of these pulses are spanning the whole globe. They are connecting the poles there. You can see some of the perturbations are going all the way across the entire planet. We see pulses coming out of the South Pacific. And it looks like a little less bleed of the South Pole toward India to me. So moving on to the earthquake situation, we'll head to the U.S. downgrade service and look at one day. All right, so yesterday there's a 5.3 in Indonesia. And let me just take that opportunity to sound like a broken record and say these areas are still experiencing a magnitude 6 and 7 earthquake drought. So please have an earthquake plan if you live there, because the drought's going to end eventually. And I think we all know how earthquake droughts end, right? There are the two warning zones. Massive drought, 6 and 7 earthquakes. Have a plan, be an asset, not a liability. If you are in a disaster, please. Here's one in Japan, 4.4. Here's a 4.6 in Greece. The antipode of Fiji. Just saying. 5.4 in the Philippines. Here's a 4.0 in Alaska. We try to only report 4.0s and higher, unless they're in odd places in the US, by the way. 4.3 in El Salvador, right in the watch zone. 4.8 in Indonesia, right in the watch zone. 4.5 in Indonesia. 4.2. There's a 4.9 off the coast of Chile. 4.7 North Atlantic Ridge. That's a more rare earthquake, at least it was before the last year or two. There's a 4.4 in the Aleutian chain, 5.1 in Indonesia. Let's check and see if there's any tsunamis been generated. Well, no warning, advisory, watch, or threat. That's a good thing. Oh man, there was a 5.3 by Kilauea. And that was days ago. We did not cover it. All right, anyway, let's go back. All right, so where were we? 4.0 in India, 4.4 in Indonesia, 4.2 in Alaska, 5.2 in Tonga, not at depth, 4.9 in Bolivia at depth. Another harbinger of larger quakes at the surface, folks. 4.4 at 273 kilometers at Japan. Here's a 4.2 at East Timor at depth. So get ready, folks. We're waiting for coronal holes here. A 4.7 at the Azores, another pretty rare spot, although it is on a plate boundary. So that is your volcano. I mean, that's your earthquakes. Let's move on to volcanoes. How's that for a segue? Now, yesterday we had a stratosphere level eruption at Bezimiani, and that continues. Let's see if we can see any footage of that. So we'll head to Volcano YT on YouTube and see if they have Bezimiani, because that is quite an eruption going on. Oh, I don't see any footage of it. Let me see if I can just do a search. No results. Let's see here. All right, we're gonna forget about that. Anyway, that thing's still erupting, and that far north, that's stratosphere level. Here's Shivaluch with a 14,000 foot ash plume also nearby. Pretty unsettling, folks. By the way, volcanic ash in the stratosphere cools the planet. Harvard doesn't. Volcanoes do. Sakurajima, Harvard is just racist. That's all Harvard does. They just deny Asian students entry. Bromo, producing a 10,000 foot ash plume. Mount Agung back to erupting. Crazy. Popocatépetl producing a 22,000 foot ash plume. So we are seeing a volcanic uptick. If you didn't know, now you know. Fuego, new volcanic emissions observed there. Revenador with a 16,000 foot ash plume. Sabancaya. Volcanoes, they be exploding. Let's look at Galaxy Zoo and classify a galaxy. By the way, we've got a story later in the stream that will talk about Galaxy Zoo. Yes, Galaxy Zoo is picked up in an article. Now let's look at this. This is a weird setup if I ever did see one. Keep in mind when you classify galaxies here, people, you need to only look at the central item. So if there are satellite galaxies around, you're only classifying the central nucleus here. So this one is pretty boring, although Oftentimes when these kind of galaxies are viewed in radio frequency, they are quite interesting. We're going to say in between. No disturbance really, as far as I can tell, because this looks like it's some kind of an optical artifact. This galaxy is probably in the foreground. So we're going to say, we're just going to say lens or arc and overlapping. And there you go. The galaxy has been classified. I highly recommend you classify this one as it's weird. It's got a bar feature. It's got a bit of a ring feature, and it's got dust lanes. So head to zooniverse.org, Galaxy Zoo. Help us classify galaxies because we need humans to do it. Computers are incapable. Let me go back to the chat here. Can anybody comment on how many people are in the chat? All right. Happy St. Patrick's Day, everybody. Welcome, Kalo Jan, our regular morning viewer. Good morning, good evening, good wherever you are. Welcome to the live stream. Newcastle. Would that be Newcastle, England? Major volcanic uptick, folks. We're getting stratospheric injection from a volcano. We don't need the Scope X program. All right, what else do we got? Are you having a late spring, Peter? Because in the U.S., we saw a late spring last year and an early winter. Yes, it's David Schlottower. All right, welcome. Did you see me last night, Schlottower? I showed up as two different names in your live stream. Daniel Nigro, my work email. All right. Yeah, there's been an uptick in the 4 and 5 magnitude earthquakes a little bit, but there's still a massive drought of 6s and 7s. Massive drought. All right, where were we here? Trying to get through the comments. By the way, glaciers form through snow. So when you have historic Northern Hemisphere snow mass, let's hope it melts over the summer. What do you say? Please increase your carbon footprint, viewers. Increase your carbon footprint. Make plants grow better. It doesn't make the planet warmer. So, yeah. All right, what else do we have here? Goat manure, nice. We use fish manure. Jaws, Phelps, and Jim are helping fertilize our plants. Newcastle, Australia, all right. Halfway around the world, cheers. And we got British Columbia, Canada, nice. All right, let's move on here to the StereoA space weather beacon. I loaded up some extra footage on it here so you can see that piece of plasma we were looking at a couple days ago. Let me blow this up so that my channel blows up when we get more subscribers and increase everything. There you go. I left the date stamps so you can see them. There's a StereoA space beacon. By the way, new viewers, if you're not aware, we are looking at the sun from right here. So you see this? That's StereoA. So your view is like, man, that's an awfully big pen. Your view is like this. And we use stereo A to see Earth-facing coronal mass ejections. All right, where were we? So we were looking at that chunk of plasma there, which just kind of, it got swiped off of the northern portion of the current sheet, and then it kind of sat there in limbo for like a day or two, and then all of a sudden it just got ejected. So a little bit of space oddity going on for you there. Let's move on to complain about the ScopeX program, Harvard's cute research group, real cute, stratospheric controlled perturbation experiment. They're trying to figure out how much aerosols to spray in the atmosphere, folks. Isn't that great? Great idea, guys. So smart. Let's click on the About tab. All right, check it out. Wow, great idea, dudes. There we go. Here are the people that are responsible for this. Please write your congressman or woman and tell them to scrap this whole program because it's stupid. Their aim is to understand the anthropogenic impact on atmospheric composition. So here's some diagrams of the stupid things that they're doing. Doesn't it make you want to invest in a fighter jet? All right, moving on. Here are your planet's locations. We'll advance this 1 week for your convenience. Mercury moves out of conjunction. And Earth is set to go past Jupiter and Saturn in the next couple months. Venus still visible in the morning sky. If you get up before dawn, go check it out. You should also see Saturn and Jupiter out there. Keep in mind Mercury and Venus, since they're planets that are far closer to the sun than the Earth, you'll only be able to see them around dawn because they're only ever a few degrees off of the sun's location, right, on the ecliptic. Just take a moment to plug our channels, such as Adapt 2030, hosted by David Dubine, a channel that I would never forget to give a plug to. And I can't zoom in right. So yeah, make sure you watch his videos. He's very interested in things like what's going on outside the US. He's located in Taiwan, and he's interested in all kinds of grand solar minimum growing solutions and taking the opportunity to help others. Because we're experiencing global crop losses already. If you're experiencing late springs and early winters where you are, so are we in eastern Pennsylvania. All right, we got to close this thing out, but let's do one article. Now, check this out. The Teacup Galaxy, which is a quasar. It's, I don't know, a few billion light years away. I will put links. Actually, you know what? I'm not putting links. You can deal with it. Just search for Storm Rages in Cosmic Teacup or go to phys.org on the astronomy section. You'll find it. Why are we covering it? Well, quasars are super interesting. And this is some kind of a radio jet coming out here. This is a composite image. The blue is the X-ray. The purple there is the optical. And then this is the radio frequency. You can see it's generating like a satellite galaxy. Anyway, quasars are cool. And why are we covering it? Oh, I'm going to get there. But for some reason, I'm not finding it. I just read the article earlier. Here we go. Located 1.1 billion light years from Earth, the Teacups host galaxy was originally discovered in visible light images by citizen scientists in 2007 as part of the Galaxy Zoo project using data from Sloan Digital Sky Survey. Since then, professional astronomers using space-based telescopes have gathered clues about the history of the galaxy, with an eye toward forecasting how stormy it will be in the future. The new composite contains X-ray data from Chandra, along with Hubble optical views. I thought there was radio views there, but it's just optical and X-ray. All right, get some radio images of it because it is awesome and very weird. By the way, these giant massive radio sources act like fountains. They act more like fountains than they do black holes, since black holes aren't a thing. All right. Next, let's look at veloshop.net, official cycling sponsor of me. So if you're thinking about buying a bike, or you're wondering what kind of bike to buy, drop them a line. Hit contact us. Drop by the store. People drive from hours around. It's also the official bike of the Lehigh Valley Velodrome. Well, let's play some music. This track is called Tilt-A-Whirl, and it's not really available for download or stream anywhere. We'll put it up someplace eventually. Let's give you a 94 angstroms view of just today. A nice green St. Patrick's Day sun. So there's the latest. We're going to do 94 angstroms. For you new viewers out there, 94 angstroms takes 5 times as many images as all but one of the other views. So there you have it. That's just today. Let me just, there you go. Now you can see the date stamp. All right, that's not big enough. Anyway, trust me, it's just today. I would not steer you wrong, viewers. So, in any case, here ends the live stream. Let me just go back to the chat for a quick minute. Any questions, comments, etc.? Pretty hard to estimate when CMEs will show up. You just have to watch. That's part of the reason why we watch every day. Yes, Carrington was studying sunspots in 1859. People were studying sunspots long before that, especially in places like China. Yes, please contact your local legislators and tell them about it. Send them a letter. Send them a handwritten letter. Great advice from David Devine yesterday. Yes, David Devine is super cool. We are looking to do lots of more material with David Devine. We enjoy the conversations greatly. By the way, we have appeared on there. Not sure which videos. I don't remember the titles, but he actually had my voice as his intro one day. So cheers. Astronomy, it'll scare the crap out of you, but you'd rather know than not know. Thank you, David. Appreciate that. David Schlottower has great content. I've never seen anybody with as in-depth of a weather forecast as Schlottower. The software that guy has and his ability to use it and understand what's in it is quite extraordinary. So thanks for that, David. Thanks, all you viewers. And keep in mind that it's St. Patrick's Day, so watch out for drunks. There's a lot of idiots out there. Now, I drive about 1,000 miles a week, and I feature lots of hacks, sometimes on my Instagram channel. So anyway, check out the links below. We appreciate your viewership. We'll be doing it all again tomorrow, possibly later today. Maybe watch our fireside chat from yesterday afternoon. There's a ghost story in there, by the way. Although I don't think it's like a ghost, like a human spirit. Anyway, remember, on St. Patrick's Day, if you drive and don't drink, and if you drink, don't drive.